Welcome to myprojectbazaar.com. Project title: Energy Efficient Optimal Power Allocation for Feeding Cognitive Radio Channels, Ergodic Capacity, Outage Capacity, and Minimum Rate Capacity. Let's see the abstract. In general, green communications is an inevitable trend for future communication network design, especially for a cognitive radio network. Power allocation strategies are of crucial importance for green cognitive radio networks. However, energy-efficient power allocation strategies in green cognitive radio networks have not fully been studied. Energy efficiency maximization problems are analyzed in delay-insensitive CR network and delay-sensitive CR network, and simultaneously both the CR network, in which a secondary user coexists with a primary user and channels are fading. Using the fractional programming and the convex optimization techniques, energy-efficient optimal power allocation strategies are proposed subject to constraints on the average interference power along with the peak or the average transmit power. It is shown that the secondary user can achieve energy efficiency gains under the average transmit power constraint, in contrast to the peak transmit power constraints. Simulation results shows that the padding of the channel between the primary user transmitter and the secondary user receiver, and the padding of channel between the secondary user transmitter and the primary user receiver are favorable to the secondary user with respect to the energy efficiency maximization of the secondary user, whereas the channel fading between the secondary user transmitter and the secondary user receiver is unfavorable. Let's see the flow diagram. First, the network formation is done, that is, it is done by the primary user and the number of secondary users with a specific base station. Then the energy efficient capacity is nominal for all the users. After that, the power constraints is verified. The power constraint strategies are under the transmit or the peak power constraints. After that, the optimal power allocation process is done for the base stations and the users. If the channel is present that is not feeding the channel, then the secondary user transmit. Or if the channel is not present means energy efficient capacity is again performed for all the users to provide channel for the secondary users. It provides a high efficiency in the energy. After that, the performance is analyzed for this energy efficiency calculation. Now see the running procedure. First, open the terminal window. Now go to the directory with the cd command. Cd space directory name, then type in a space file name .tcl. Here 12 nodes are created and the coding is running now. Here the updated energy is displayed and the node position is also displayed. This is displayed for the consideration of the green, that is the energy efficiency. This is a network unlimited window. In NS2 we see the simulation in this window. These are the number of nodes. To run the simulation, click the play button. Now the channel is providing for all the nodes so that we can see the channel provision process. Then this is the simulation time that running here. We can speed up the simulation. This is the primary base station and here is the cognitive base station. These nodes are the primary users and these are the secondary users. The primary user is communicated with the primary base station with the available channel. Here the secondary user is provided the request for accessing the channel to the cognitive base station. If the channel is free for the primary user, then only it gives the channel to the cognitive base station. The requests are saved here. Now the channel is free now. Hence the cognitive base station access channel from the primary base station. Since the distance is long, it provides the channel from the routing process, which are the intermediate nodes act as the relay and forwards the data to the cognitive base station. That is, it gives the channel for the cognitive base station, which are used by the secondary user. So these are all done by the energy efficiency, which we see the energy for each and every node. So that is how many energy are spent, which is called as the residual energy, are all displayed in the terminal window. In a situation of accessing the primary user, again the secondary user stops the transmission process. To see the performance result, the graph will be shown. This is the relay graph, which is calculated for the transmission and the receiving power, and this is the energy calculation, and this is the throughput graph for the transmitted packet and the receiving packet, and this is the packet heavy ratio graph. All the processes are done for the proposed system.